Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 1C assignment. Okay. Number one, state the accuracy of the following measuring devices. A tape measure marked in centimeters. So what you want, the easiest way I feel to do this is to figure out, okay, it's down to the nearest 1 centimeter. So I'm going to take 1 centimeter, divide that by 2, and that gives me 0.5 centimeters. Okay. So that means the accuracy is going to be plus or minus 0.5 centimeters. So if we said that it was, say, 33 centimeters, if here's our ruler, right, and let's say this is 33, 32, 34, that means that this measurement is going to be somewhere in this range right here, because if it was a little lower, we'd round down to 32. If it was a little bit higher than 33 and a half, we'd round up to 34. Okay, so it's accurate to plus about half of a centimeter. All right, same thing here. A thermometer marks every 0.1 degrees Celsius. So that means it's measured to the nearest 0.1. We take half of that, and that gives us 0.05. So it is accurate to plus or minus 0.5 degrees Celsius. So within 5 hundredths. Okay. All right. Find the range of possible values corresponding to the following measurements. 4.8 meters. We're always going to be pretty much looking at the last significant figure on this here. So we've got 4.8 meters. So that is to the nearest tenth. So I'm going to do this 0.1. So I'm going to take 0.1 divided by 2, and that gives me 0.05. So I know that it's accurate to plus or minus 0.05. So then what I do is I take 4.8 and I subtract 0.05, and then I take 4.8 and I add 0.05, and then this is going to be my range. Right, so I'm going to borrow one from that. 5, so it's 4.75 to 4.85. That is what it should have been. If you measure something and it's between 4.75 meters to 4.85 meters, you're going to round it to 4.8 meters if you're going to the nearest tenth like they did here. Okay. All right, Tom's digital thermometer said his temperature was 36.4 degrees Celsius. In which range of values did Tom's actual temperature T lie? So it measured down here to the nearest tenth, which is 0.1. Divide that by 2, and it's 0.05. So it's plus or minus 0.05. So I'm going to take 36.4 minus 0.05. I'm going to take 36.4 and I'm going to add 0.05. So borrow one from there. I'm going to get 36.35, 2, and then you add those together and you get 36.45. And then this is degrees Celsius. So Tom's temperature is somewhere between 36.35 to 36.45 degrees Celsius. Okay. All right. Hassan has many lengths of rope. He's measured each length to be 2.4 meters. In what range of values does the actual length of a rope L lie? So this is to the nearest tenth. So for A, nearest tenth, 0.1, divide that by 2, and that's 0.05. So we're going to add and subtract 0.05 to 2.4. 2.4 minus 0.05 and 2.4 plus 0.05. That's going to give us 2.35 to 2.45. So that's the actual, and what range of values is the actual length of rope L lie? Between 2.35 meters and 2.45 meters. It's a good idea to put your labels on these just so there's no confusion at all. If Hassan carefully places n of his ropes end to end in what range of values will the total length of rope L lie? So he's got n of his ropes. So the shortest, they could all be 2.35. So we could have 2.35 times the number of ropes. Could be the smallest, 2.35 times that. And then the biggest could be 2.45 times the number of ropes, right? So what values will the total length of rope L lie? So L is going to be greater than or equal to 2.35 times the number of ropes, and it's going to be less than or equal to 2.45 times the number of ropes. Okay? And again, I should put meters in here. Meters. Okay? Let's look at the next one, 9. A rectangular bath mat was measured 86 by 38. Find the boundary values of its perimeter. So 86, that's to the nearest 1, divided by 2, 0.5. And 38 centimeters, that's also to the 1. So we're going to add plus or minus a half to each one of those. Right, so we've got 86 minus 0.5 and 86 plus 0. Oops, let's get that in the right spot. Plus 0.5. That's the one of the ranges, and then the other one is going to be 38 minus 0.5, 38 plus 0.5. Right? So we just do the math. 86 minus a half is 85.5. 86 plus a half is 86.5. And then that's 38 minus a half is 37 and a half. 38 plus a half is 38.5. So find the boundary values of its perimeter. So the shortest it could be, if we're going to, let's do this. We'll draw ourselves out a mat. Couple of mats. So here's the short value, shortest possible, and then we also got the same one that is the biggest possible, right? Biggest. So the shortest it could possibly be is on these long sides, it's 85.5, and on the short sides here, it's 37.5. And on the biggest, it's 86.5 on the long, 86.5, 86.5, and on the short, it's 38.5, 38.5. Okay, so they didn't ask you to do a visual representation, but I figured I'd draw it just so you kind of get an idea. So add these all up, that's the shortest. And then add these all up, and that's going to be the longest. So basically, it's easy way to do that is 85.5 plus 37.5, and we double that, right? So let's do this here. So we've got 85.5 plus 37.5, and that's 123, and we double that. That will give us a perimeter of 246, right? And then we can also try then this other one, 86.5 and 38.5. Okay, add those together, 125, multiply that by 2, and that gets us up to 250. And these are all in centimeters. So that means the actual boundary values could be anywhere from 246 centimeters to 250 centimeters for its perimeter. Okay. Let's look at number 11 here. A rectangle is measured to be 6 centimeters by 8 centimeters. Find the largest area it could have. So these are both to the nearest centimeter. So we take 1 divided by 2, and that's 0.5. Since we're looking at only, on this one here, we're only looking at the largest, we're going to take 6 plus 0.5 is 6.5 is the largest it could be, and then we'll take 8 also plus 0.5, and that gives us 8.5. 0.5. So the largest it could possibly be would be 6.5 centimeters by 8.5 centimeters. So then we would just simply take 6.5, since we're looking at area, times 8.5, and that would be the largest area we could possibly have for this here. So 6.5 times 8.5 gives us 55.25, and this is centimeters, since we're talking about areas, centimeters squared. Okay? All right, last one we're going to take a look at here is find the range of values in which the actual volume, V, of a house of brick measuring 21.3 by 9.8 by 7.3 must lie. Okay, all of these are to the nearest tenth. So 0.1 divided by 2 is 0.05. So that means, excuse me, we all of these could go plus or minus 0.5 for each one of these measurements. All right. So volume is length times width times height. So we have to add and subtract from each one of these. So let's do this. 21.3 minus 0.05. 21.3 plus 0.05. And we'll set this up for all three of these measurements. Okay. So this is going to be 21.25. This is going to be 21.35. 9.75, 9.85, 7.25, and 7.35. So the smallest it could possibly be would be all three. Let's do this in red. These would be the three smallest possible measurements, and then the largest would be these three, because those are all the biggest possible measurements. So if we're doing the smallest, we would do 21.25 times 9.75 times 7.25. And then for the largest, we're going to do 21.35 times 9.85 times 7.35. Okay, so let's figure out what both of those are. And away we go. 9.75, 7.25. Right? You got those right? Okay. Push equals, and we get 1502 point, and it doesn't give us anywhere to round off to, so I would just assume, let's just go to, I don't know, I guess probably the second decimal. It's not a huge thing. They don't specify, but I would go probably, since these are two decimals, I'm going to go to two decimals here. So that 9 tells the 0 to get bigger. So 1502.11. And this is centimeters cubed, because we're talking about volume here. And then for the big one, we've got 21.35 times 9.85 times 7.35. It equals there, and that's 1545.69. And that's also centimeters cubed. Okay, so then that means our range on this one would be 1502.11 cubic centimeters. Would be, the volume would be greater than or equal to that, but less than or equal to 1545.69 centimeters cubed. Okay? All right. That's all we have for these here. If you have any further questions on any of these or other problems from this section, please feel free to ask. Thanks.